In this video, I'd like to talk about the math question of the day for February 9th, 2023. And we need to evaluate this expression here, which is an exponential expression with a negative rational exponent or a fractional exponent. So to solve a problem like this, you need to have a solid understanding of pre-algebra with exponents, but you will likely need Algebra 1 and Algebra 2, where typically students will learn how to deal with fractional or negative exponents. So at this point, go ahead and pause the video, see if you can solve this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted this problem, we can work through this together. And if you do have suggestions for future videos, please leave them as a comment down below. Now, to understand this problem, we need to think about, first of all, what it means to have a fractional exponent, and second of all, what it means to have a negative exponent. So let's start with a fractional exponent. Let's say we have some number a, and we'll make a positive number just to make things simpler. And if a is raised to some fractional power, let's say b over c, then we can rewrite this as the c root of a to the b power, or as the c root of a all raised to the b power. Either way you do this, this is true. But the general idea is that the denominator of the exponent is the root that you're taking. The numerator is just what you're raising that number to, or what power you're raising that number to. So if, let's say, we have 2 to the, let me actually use different numbers. Let's say we have 8 to the 4 thirds. Well, we would be taking a cubed root of 8 and then raising all of that to the 4th power. Or we take 8, we raise it to the 4th power, and then take a cubed root of that. Either way you approach this, you will get the same value. And typically, it's simpler to evaluate the root first, so that you can make it a smaller number and then raise that small number to whatever the power is. For instance, if we raise 8 to the 4th power, that is a fairly large number, and then we need to find the cubed root of that number, which in all likelihood you won't know off the top of your head. So the way that I would approach this is to use this method. Take the cubed root first. The cubed root of 8 is 2. We raise 2 to the 4th power, which is 16. Now, a negative exponent essentially just means repeated division. Since if we have, let's say, 4 to the 3rd power, this is just repeated multiplication. So positive exponents mean multiply this number this many times. But if we had, let's say, 4 to the minus 3, this just means take this number, the base, and divide it this many times. So it's just repeated division. So we have 1 over 4 times 4 times 4, where all of the 4s are in the denominator. We are dividing by 4 3 different times. So in this case, we get 1 over 64. So be careful with negative exponents. We don't end up with negative numbers. We end up with fractions, since we are doing repeated division. Now, the other way to see this is, let's say we have 8 to the minus 6. We can just rewrite this as 1 over 8 to the 6th power, where, again, we are dividing by 8 6 different times. So now that we understand fractional and negative exponents, let's actually consider this problem. And we can consider the negative at the end. So let's use exponent properties to rewrite this as 8 to the 343, excuse me, 8 over 343, all raised to the minus 2/3 power. We can actually essentially factor that negative out. Since remember, when you have an exponent raised to an exponent, that you multiply. So we could think of minus 2/3 as just really minus 1 times by 2/3. And we can rewrite this as 8 over 343 raised to the 2/3 power, and then all of that raised to the negative 1 power. And from here, we can evaluate this fractional exponent. Now, I do also want to mention, if we have a fraction raised to some power, let's say we have 2 over 5 raised to the 3rd power, You're multiplying this fraction out 3 different times in this case, and the numerator will be multiplied 3 times, and the denominator will be multiplied 3 times, so that we get 8 over 125 here. But the general idea is that if you have a fraction and it's raised to some exponent, that exponent in effect is distributed to both the numerator and the denominator. Now, it is different than distribution, but you could, in some sense, think about it that way. So we can rewrite this down here as 8 to the 2/3 power divided by 343 to the 2/3 power. And then all of this is raised to the -1 power. And we can evaluate each of these individually. So let me just make a bit more room here. We can do 8 to the 2/3. And remember that the denominator just tells us the root we're taking of our number, and the numerator just tells us what power we will raise that to. And as I mentioned earlier, it's usually easier to take the root first and then raise it to the exponent. And we know the cubed root of 8 is just 2, and 2 squared is 4. So 8 to the 2/3 power is 4. And you could, of course, check this with a calculator. Just be careful. Make sure that your exponent is in parentheses so that the calculator reads the order of operations correctly. So we figured out the numerator, that's just 4. The denominator, we can do 343 raised to the 2/3 power. We'll follow the same approach. We will do the root first. So we need the cubed root of 343, and we will raise all of that to the 2nd power. And the cubed root of 343, what number multiplied 3 times by itself gives you 343. That is just 7. So this is 7 squared, and 7 times 7 we know is 49. So now we can continue evaluating this expression. And we have in the numerator that 8 to the 2/3, that is just 4. The denominator, 343 to the 2/3, that is 49. And all of this is raised to the -1 power. Now remember, the negative exponent is just repeated division. So we will be dividing by this number 1 time. So we have 1 over 4 over 49. And remember, when you're dividing by a fraction, it's the same as multiplying by that fraction flipped over, or multiplying by its reciprocal. So our final answer is 49 over 4. And in general, when you have some fraction, let's just say a over b raised to the -c power, that negative will just flip the fraction. So it becomes b over a, and then the exponent becomes positive. So you could memorize things like this, but ultimately you can understand this by just remembering that the negative exponent means repeated division. So this is what we think is the final answer, but this is something we can check on the calculator. So when you type this into your graphing calculator or whatever calculator you use, just make sure to use parentheses around the base and put the entire exponent in parentheses so that, again, that calculator reads the order of operations correctly. But when you do plug this into your calculator, you will get the same answer. It will actually give you the decimal, 12.25, but that is equal to 49 over 4.